Hi everyone, how are things going? I hope all of you are doing well. You are watching a video recording for the course IST 261 Application Development Studio 1 at Penn State University. This course takes place every Monday and Wednesday from 4 p.m. to 5:15 p.m. Today is the second class of the semester, so we are going to talk about the basics of Java and why it's a reasonable language to learn. Okay, let's get started. Some student sent me email to ask these questions like, okay, how will this course be delivered? Again, we will pre-record all the lectures, and because this is a studio course, so the lecture will not be like full length. It will be around 20 to 60 minutes each time, and I will record the video and send the video to the entire class before each of the class meeting. And during the class time, I will host a in-class office hour between 4:30 p.m. to 5:30 p.m. on Monday and Wednesday, right? Okay, and we will start office hour next week. That's the plan. And this week is kind of like planning phase. We are still discussing all the details. And I understand many of you ask some questions via the Google form we send out, and I will collect all of those questions and answer them together next week, probably on Monday. Okay, so don't worry too much about that. So today we are going to talk about the basics, very, very basic of Java, and I'd like to start the course discussing about why we are learning Java, right? And I want to start with the elephant in the room, is that why do people don't like Java? And there are probably four main reasons people don't like Java. First, it's very old, which is probably true. It's pretty old. I started learning Java since when I was like 18, and it's still around, and it's pretty old. And the second reason is it's very commonly mentioned by people is that Java is very verbose. Verbose means that to do something, the amount of text you need to write to make that implementation happen is much longer if you compare with, say, Python or even JavaScript, which is kind of true. And the reason why I believe it's not a problem is because most of the IDE, the editors you are going to use are aware of this problem. Everyone, pretty much every editor knows the Java is a very verbose language, so it will give you additional support to, for example, it will automatically populate the functions. So method names, you can just click and it will kind of provide more support. So I would probably argue that it's not as verbose as most people like to think. I personally wrote Java for probably 10 to 15 years. And at the very beginning, yeah, I mean, if you think about, for example, if you just want to print something on the screen, in Python, it's just print. But in Java, it's system.out.print or print line, and then it's the content you want to print. That is much longer, right? But if you get used to it and you write Java pretty often, it's not really a problem. And I will also argue that the reason why it's so verbose is because Java is more strict and it takes care of many error cases, and it gives you a more robust support. For example, if something happens, something bad or weird happen, it will actually give you the capability of capture the error and give you a better understanding and representation of the error. And some people would argue it's heavy and slow. I would say it's probably true 5-10 years ago, but it's not true anymore. It is probably still heavier than, say, Python or JavaScript. But if you are talking about a full stack application, I would not say JVM or Java is the heaviest option you can have, right? There are many other framework out there is also very heavy, and they can do fancy stuff. But I would not say the language itself is heavy. It's not a language problem. It's usually the framework or the implementation's problem. And people kind of want to like to say Java is slow. It's definitely not true anymore. Many people feel it's slow because the IDE implementation they use. For example, many people feel like Eclipse, it's much slower than other editor or even other Python editor, which is probably true. But I would argue when you reach to the application phase, it's not as slow as many people want to think. And actually, many modern framework or OS or infrastructures like Android system and Spark, and even earlier MapReduce are implemented by Java, or at least the foundation of those frameworks are Java, and they are not slow. They are not known to be slow. There are a lot other things are much slower. So I would say it's not true anymore. And probably many people will think it's slow to write. And this is the argument I kind of agree, because if you compare against Python or JavaScript, yeah, I would probably agree Java is slower to write. Even you master the language, it's still kind of slower to write. I mean, for example, I am relatively experienced in Java, and it still takes me slightly more time to do certain things than my friends who is mastered in Python. So, but in return, Java gives you a lot more control, in my opinion, to your code, and you try to make sure you do things in the way that you think is correct. And once you follow the Java convention and you follow the principle of OOP, your code will be very robust. And when you master Java, I would probably argue that it's harder to make certain types of mistakes that is easily you can make in other language. So there are good things and bad things about Java, right? And on the other hand, why Java is a good language or why we're learning Java, right? Java is popular. Like most people don't think it's popular, but in reality, it's actually very popular. If you look at the survey, large scale survey, it has, I think it's 50,000 or 60,000 participants. And if you look at the survey result from Stack Overflow, last year, 2019, it's still going on for 2020 right now. So if you're interested, you can go to Stack Overflow and take their survey. And they ask what is the most popular language. And among professional developers who are doing coding for a living, right? It turned out Java is still a pretty popular language. It's even more popular than C# and PHP, and it's pretty close to Python. It's pretty similar to Python. And it's not very surprising that the most popular language are JavaScript and HTML, which you can use to build web pages. And SQL is like database language, so you will probably use it very, very often. But Java, it's not very surprising to me that it's still very popular. And so it is still a very important language into the world of 2020. And again, why Java, right? And one advantage of Java is that Java works on different platforms, and that's probably also why Android decided to use Java. And it is one of the most popular programming language in the world. And of course, like I said, Java has been around for very, very long time. It's like 20 years-ish. Because of that, it has a huge community support. So if you have encounter any problem, you Google it and you can easily find a lot of answers. And that's actually a good benefit for programmers, right? And I mean, Java is an OOP language, and that's give a clear structure to programs and allows code to be reused, lower development costs. That is still true, just that nowadays, because Java has been around for so long and people started to learn that, well, OOP is not solution for everything, right? It's still have some downside and trade-offs. But if compare with the world before OOP, of course, OOP will give you some clear benefit. And OOP basically force you to think your code, your implementation in a way that you need to isolate different components, and you are forced to think how they interact with each other, which is a very good way to think about your code. So that's the benefit of Java. And if you are interested, you should go to the Stack Overflow to see the detailed result of the survey. You will probably learn that, okay, Python is popular, but Java is a very valuable language to the world we are in right now. So today I am going to talk about the basics of Java. And by the basics, I mean the syntax and method and class of Java, which is like Java 101. And the reason why I'm doing that is because in the survey question, a few students, some of you never used Java before, and several of you said that you have only limited experience in Java and you know the basics. So I want to recall your memories of Java, no matter if you took several classes or used it once or twice before. I want you to get familiar with the language again. And if you go to go on internet and search for Java tutorial, you will find a lot of tutorial that teaches you basics about Java, and that's what I'm going to do. And I encourage you to go to this job w3schools.com/Java. They have a very simple and easy to follow tutorial of Java. So that's what I'm going to do. And of course, if you are already pretty experienced in Java, or you believe you understand the basics of Java, you can probably skip the remaining part of today's course, which I'm going to talk about the syntax, the class, and the method. They are all really basic. So let's get started. So here is the basic Java syntax, and let's assume you are going to create a class called my class. So basically, you are going to write a file. It's called myclass.java. The extension name is .java, and the basic structure is like this. You have a class name. Here is a public class, my class. So you just write it public class, my class, and inside the scope of that class, you have a main method, which means that if you run it as your main class, it will just run the main method, and here you print hello world. This is probably the easiest way to understand the syntax. You have a class, and everything in Java is class. The language forces you to think about everything from a class perspective. And so you write a class, your main class, and inside that class, you have a main method. Means that when this function called as a main, when this class is called as a main class and run as a main class, it will look into the main method, which is print hello world here. So that's the basic. And another thing to know is that the commands in Java looks like this. You use basically /, and you can basically the command symbol tells the interpreter to ignore everything after the command symbol, meaning that, for example, in the first example, it says this is a comment, and it basically the entire sentence or comment will be ignored by the interpreter. And also it has a different form, which is long comments. means that you use a slash start to specify the scope of your comment. The third example here, it says the code below will print the words hello world to the screen, and it is amazing. But the entire part will be ignored. You basically use these symbols to tell the interpreter that this part of code should be ignored, and you can use that area to take notes or to explain what's going on in the next chunk of code. And variables. So here are the native classes or types of Java. It has string, integer, denoted as int, and float, and chart means character, and boolean, right? And basically, these are the native type come with Java, meaning that you don't need to import extra package or dependency. You can just use it. The way you use it is that you declare the type and you declare the name of the variable. And if you want, you can assign a value to it. Here we have an example. The string, if you have a string and you give it the name, you give it a variable name, here is a name, string name equals to John, right? So you basically create a variable, and the name of that variable is, the content of that variable is John, and you can print it. And so basically here are examples of Java data types. So you can see you have integer, it can, and it's just an integer, and float. Float, it basically means floating point number, and it has a different type of format, but basically it's just like pretty similar to all other floating point numbers in all other different languages. And characters, my letter, in this example, the character variable name is by letter and assign it with D. And the difference between character and string is that the character use single quote and the string use double quote. However, I would probably say character type, it's not used very often because in Java, the string is actually a class, and string can give you a lot more support, allow you to manipulate the string. So many people just use string to manipulate characters instead of just directly operate characters. And boolean means that you sometimes you need to create a variable and it denotes true or false, and usually used to decide the flow or if then statement of a code. And strings. String is basically it's a type, but it's also a class. So like I said, it comes with a set of a method you can use to manipulate the string, but we'll probably talk about that later. So again, booleans means that you can, for example, in this example, the first line says boolean, and the name of variable is Java font, and assigns it with a value true. And because it's a variable, you can of course print it out. So like I said, right, in Java, to print something out, you need to write down system.out.println, and then the bracket, inside a bracket, you need to put in the thing you want to print out. Compared with other languages, arguably longer, right? But it has a reason, because it gives you capabilities of controlling all the details of this print and allows you to catch all the exceptions or errors when anything goes wrong. So this is also very basic. It's a if-else statement. Pretty much all other languages has similar statements. So first, we need to talk about operators, right? And here are a list of operators you can use to compare two variables. And I like to be clear, this operators works only for native types, but it does not really work for strings. String, you need to use the method count with string to compare two strings, like dot equal or equal to, something like that. But for integer floating points, you can use these native operators. For example, you can use less than, A is less than B, or A is less than or equal to B, A is greater than B, A is greater or equal to B, or double equal means A is equal to B. And you can use not equal to, A is not equal to B, right? So these are all the basic operators you can use in Java, and this is pretty similar to all other common languages. And in Java, you also have if, else, else if, and switch, right? So if looks like this, is like if, and you have you state the condition, and if this condition is true, you just execute the block of code inside the scope of if. And if else means that, okay, if the condition is true, run the first block of code, and if it's not true, you run the block of code in the scope of else, right? That's a very basic concept. And of course, in some case, for example, when the case, you don't just have if else, you actually have a list of different cases. You can use switch, means that you say switch, and the interpreter will look into the expression and check if the expression's value equals to X or Y or Z. And if it's X, it goes to case X and run the code block after case X. And if it equals to Y, the interpreter will jump to the case Y and run the code block of case Y. And default meaning that if nothing matches, right, it will just run default. And while loop means that it's also a condition, means that if the condition you state is true, the while will continue running the code block inside the scope of while loop. And so you can imagine one common error that happens is that the condition will always be true or always be false, right? Nothing changes over the execution time of the loop, so that the either you're stuck inside the loop forever, or you never reach inside the while loop. And the for loop is also a very common in programming language. Most programming languages have this. And let's start with the example, right? Usually you use a for loop to count things, and that, for example, you start counting from I equals to 1, you have integer I, and you start counting from 1. And if I smaller than 5, you just continue. And every time you continue, every iteration, I will plus 1. That's what it says. So in the abstract level, the for loop has 3 statements. The first statement is the starting condition. You say, okay, I will start with I equals to 0. That's your starting point, right? And the statement 2 is the continue condition. In what condition the loop will continue to iterate. And in the example, the condition is I smaller than 5, right? So if this statement is true, the loop will continue. And every time it iterates, it will execute the statement 3, which is I plus 1, meaning that you start counting from 1, and every time if it's smaller than 5, it will iterate and execute the block inside the loop. And every time you do that, the I will plus 1. So in this example, it will basically print out I every iteration from I equals to 0, 1, 2, 3, 4. And after executing after 4, the I will no more smaller than 5, because the next iteration it will actually equal to 5 and it will leave this loop. And here is arrays, right? In Java, array is also pretty straightforward. You basically state the type, and you just use the corner bracket to state, to basically specify it's a array. And in this example, it shows a string array, and you can basically list all elements inside this array, use comma separated list. And the good thing is that this format basically applies to all the native types too. So you can use it for string, you can use it for integer, or you can use it for your own class. So that's a very easy way to state the array in Java. So let's take a look at the, I think it's probably the best explanation I can find on the internet about the class and the method in Java.
So what are classes and objects? I think the best way to explain what they are would be to give you a really concrete example. So let's say, as an example, you're thinking about making a website where people can, visit and talk to a bunch of robots. So what you have in mind is, when people feel lonely or something, they can come visit your website and say hi to one of the robots there. So when a user comes to your website, they might see a list of robots like this. And here you see two of those robots, and they're called Tom and Jerry. Aside from their names, they have some obvious differences. First of all, Tom's color is red, while Jerry's color is blue, as you can see. And Tom is slightly lighter in weight than Jerry, with 30 pounds of weight, while Jerry is 40 pounds. And they both have the same functionality. When you click this button, introduce, Tom will say, "My name is Tom," and Jerry will say, "My name is Jerry." And that's all you have for now, and it's pretty basic, but that's all you want at the beginning when you create this website. Now, to create a system like this, you basically need a way to represent these different entities or these different robots in whatever programming language you're using, whether it's Python, Java, or JavaScript. And that's where classes and objects come in. Now, to represent each of these robots, Tom and Jerry that we saw earlier, in whatever programming language you're using, you need to store two sets of information. The first set of information that you need to store is the properties that each robot has. So for example, the first robot we saw had these properties. Its name was Tom, the color was red, and the weight was 30 pounds. And the second set of information you'll need to store for each of these robots is the set of functionalities it has. As we saw earlier, it had only a single functionality in this particular case, and that was to introduce itself. And that might be represented as a function in whatever programming language you're using. And let's just call it introduce self here for now. At this point, you might say, is there any convenient way to organize these properties and functions together? There is, and that's called an object. An object is basically a collection of properties which can be expressed as variables and some functions. And with that collection of information, an object can represent something, whatever that thing is. So in this particular case, this particular object is representing this particular robot, Tom, but you can make an object so that it represents a particular person or a particular dog or anything else for that matter. If you decide to represent a particular person with an object, let's say Lady Gaga, just as an example, you might have a different set of variables and a different set of functions to represent that person. So for example, you might still have name, but you might also have height and weight, eye color, and ethnicity, and so on. And your object will probably have a different set of functions too to show what kind of actions that person can take. It could be, for example, things like walk, sleep, talk, or anything a person might do. Okay, let's backtrack here a little bit. Once you create an object to express this particular robot, Tom, you'll be able to put this object in a variable just like that. Let's say R1, just as an example. And you'll be able to use this variable that contains this whole set of information, the properties or the variables and the functions, just like any other variables. For example, to pass it into a function as one of the arguments. Okay, let's now take a look at how the second robot we saw, Jerry, can be represented with an object. It's going to look pretty similar to the first one. It's going to have the same set of properties, but different values. This time, Jerry, blue, and 40. And the same function as well, introduce self. And of course, once you create this object, you'll be able to put it in a variable as well. Let's call that one R2. And because you have two distinct variables containing two different objects, you'll be able to distinguish them very easily in your code. And just quickly about terminology, these variables within an object are called either instance variables or attributes, and these functions within an object are called methods. Okay, so when you see these two objects, you might say, well, they're pretty similar. They have the exact same set of variables or attributes, and they have the exact same set of functions, only one function in this case. So you might say, is there any convenient way to organize that somehow? There is, and that's what a class is essentially. Now, what's a class? A class is basically like a blueprint from which you can make objects. So just imagine for a second someone telling you, please make a robot. If someone tells you something like that, you'll say, what kind of robot do you want? What should it look like? And what kind of properties should it have? And what kind of functionalities should it have? So basically, if you want to make a robot in sort of the real world, you'd need a blueprint to make that from to know what the robot should look like. And that's sort of how it works with programming, with objects and classes too. So when you make an object, you'll want to know what kind of properties, what kind of attributes it'll have, and what kind of functions it'll have. And you can use a class to specify exactly that. Okay, let's now see what this particular class might look like for these two objects, these two robots. It'll probably look like this. As you can see, it has the same set of properties as the objects themselves, name, color, and weight, but the values for these three properties are not defined yet. And that's because a class doesn't refer to any particular object. It doesn't refer to this robot or this robot in particular. It just refers to this category of robots or this type of robot in general. And then when you create a specific object using this class, then you can specify what the name should be, what the color should be, and what the weight should be. And also notice here that we already have the introduce self function in this class, and you can actually implement it already when you define this class by writing something like this. So this is just an example from Java. In Java, for printing something on your computer, we have system.out.println. It's similar to the print function or the printf function in other languages. And then inside the input of this function, we have my name is as a string plus name. And this name will refer to whatever the value of the name is for that particular object. So for example, if you run this function in this object, it's going to print out my name is Tom, because that's the name of this particular object. And then if you run this function here in this object instead, it's going to print out my name is Jerry instead. And one more thing to note here is that when you define a class like this one, you need to give it a name. It could be anything, but let's call it robot here. And as you can see, the first letter R is capitalized, and that's a pretty common convention when you name a class.
Yeah, that's a very good introduction about class, method, and properties. So in Java, what are classes and objects? Basically, a class describe a abstract type of things, right? In this example is fruit. And objects means the realization or an object or an item in that class, meaning that you can say, okay, I have an apple, I have a banana, I have a mango, and that's the concept of object. Again, class is basically a template of items. You can look at the bottom line here. So basically a class is a template for objects, and the object is an instance of a class. It's a realization, it's the created instance of that template. And so here is an example. Again, continue our example with my class, right? You can create, you can specify a template. It's called my class. And inside that class, it has a integer as the property, and you can specify the value of that integer is 5. That's a very simple example. And the method inside class, again, is if it's a method inside the class means that when you call that object, when you create an instance of that class, when you create an item of that class, that object or that item come with that method. Means that, for example, you create a class and that class has a method called my method. And every time you create a object of my class, it will has that method. So you can call my method. Doesn't really matter what it does. And how do you actually create an object in Java? You use the command new. Here we have an example. My class, you basically create a object called my object by new, and you just say new my class and with a bracket. Means that you create an object from this class template, and you can then you have object in your hand. You can manipulate and you can call the property, you can call a method inside. You can basically operate or manipulate the object once you create it. So here again, so you can access to the attribute or the property of an object once you created it. So here in this example, you can see I create a object from my class, right? My class, my object equals to new my class. And then once you have my object here, you can use dot x, means that, okay, I know there is a integer inside this variable, inside this object called x, and I want to call it, and I want to, for example, see the value of this property, and I want to print it out. So again, the class can have attributes, and the way you access to those attributes is use dot, right? You create an object and use dot. In this example, you create an object called my object, and you use my object dot x to call the attribute, and you can print, in this example, print out the value of that property. The last thing I want to talk about is the constructors. So the concept of constructor is that, okay, you have a template, you have a class, right? You have a class and you want to create an instance of that class. For example, you have a class of fruit and you want to create the instance of fruit. However, the every time you create a object or you create an instance, there are something you need to do to initiate the object, and where you can specify all the process of initiating a object. That is the constructor. And the constructor in Java it need to be specified in the function that has an identical name as a class, meaning that if your class is called my class, and the constructor's method need to be called my class inside my class, right? So in this example, you can see it has a public method called my class. And what it does in this example is to assign 5, the integer value 5, to the variable x. What's the benefit of that, right? Why don't I just easily assign x? That, I mean, in reality, the reason is that every time you create a new object, maybe there are many things you want to do. You want to assign certain values, you want to assign, you want to create a new list, or you want to do some configuration. And those configurations or startup steps are very often depends on your need and your input. And if you isolate that step as a separate function or separate method, it allows you to customize for it, right? If, for example, you can have different constructor for different classes, so every instance can be initiated in a very different way. And we will probably talk about that later, but you need to, at this point, you need to remember the constructor means that you can do something to specify the initial step when you create a new object. So like I said, today I will just cover all the basic concept of Java. And if you feel confused or you feel this is too fast, don't worry too much about that. Next week we will have a first assignment. I will make it an easier assignment. And the goal of that assignment is to get most of you familiar with Java again, and familiar with all the basics of Java again. And I will slow down a little bit and that you to actually write some Java code and to get you familiar with the IDE and Java. Okay, thank you very much. See you next week.